What's up, everyone? In this video, we're going to be going over some concepts of rotations. So remember that when we rotate a figure about a certain point, we need a degree or how much we are rotating it, and we also need to know what we are rotating around. So in this first example here, we are going to find the image of triangle BCD, and make sure in your notes you are changing the coordinate of D. The y value should be positive. And we are rotating this 90 degrees about the origin. So the origin is this point 0, 0, so that's our center of rotation here. So remember, our center of rotation never changes. So what I like to do is I will highlight my axes because it kind of gives me a better visual understanding of what's happening here. Now, what you can do for all of these questions is you have these coordinates, right? You have coordinates B, C, and D, and we know I'm rotating 90 degrees. So I know that point D is going to end up about 1 quadrant over. Point B is also going to end up 1 quadrant over. And point C is also going to end up 1 quadrant over, right? That's usually how it goes. We have quadrant 1, 2, 3, and 4. And our standard direction is counterclockwise. So we know that points D and B are going to end up in this region here, and we know that point C is going to end up in this region or this quadrant over here. So to help us figure out what those points are, what we're going to actually do is turn our paper 90 degrees clockwise. And what that's going to do is it's going to help us emulate where our points are going to end up. So we're going to pretend like this is our X and Y axes here. And all we need to do here, if we're looking at our picture like this and we just plot these 3 points that we have, we're going to find the images of all 3 points. So point B is 7, 1. Now we're pretending that this is our new x-axis and this is our new y-axis. So if this was our new origin here, 7, 1 is 1, 2, 3, 4, 5, 6, 7, 1 is here. This is going to be the location of B prime. For point C is at 6, -6, so we do 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. That's going to be our C prime, and then our our D prime is at 2, 5. So if this is our newfound origin with our new X and Y axes, we get 1, 2, 1, 2, 3, 4, 5, and that would be D prime. Now if we go ahead and take our straight edge and connect these points, we get a triangle that looks like that. Now, again, if we flip back, let's see if our estimates were true, right? We said D and B were going to end up in this quadrant here, which they did. And then we said point C is going to end up 1 quadrant over, which it does. So the trickiest part about this is we're going 90 degrees counterclockwise, but we actually rotated our paper 90 degrees clockwise to emulate where those points are going. So again, biggest concept here is seeing where your X and Y axes are, seeing where your center of rotation is, and then just rotating and just replotting these points, pretending that this was our X and Y axes. Now, when you're stating the points though, you need to make sure that you are stating the points in terms of your actual axes. Whenever you're stating points, it's never going to be, oh, the point is 7, 1 when it's rotated. No, you have to state, so this again is your origin, so the location of B prime, when you're actually looking at your axes straight on, is -1, 1, 2, 3, 4, 5, 6, 7. The coordinates of C prime are over here, so that's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And then D prime is over here, and that's -1, 2, 3, 4, -5, 2. Okay, now let's move on to a slightly different example, where here we are using the same exact points. So on your second question of your notes, make sure you write these 3 points in. I'm not sure if it's different, and make sure your Y value of your D point is a +5, and change your rotation rule. We're doing a rotation of 270 degrees again about the origin. So our center of rotation is here. I always like to label that because after we label our center of rotation, I like to take a highlighter and just mark what's happening here. Now, again, we have the same exact points, but now we're rotating 270 degrees here. Now, again, this is where it clashes a little bit based on what we did the other day, but we're rotating 270 degrees. So, again, now instead of D and B ending up in this quadrant over here, so this would be a 90-degree rotation. D and B over here would be a 180, and then we're moving 3 quadrants over. This is 3 90-degree rotations. You can kind of think about it that way, right? So again, what we did before to emulate this 90-degree counterclockwise rotation, we went backwards. We put our paper 90 degrees clockwise, and we replotted those points, right? Now for this example, we're gonna do the same thing, but instead of going one 90-degree rotation, we're gonna do 3 of them. So this would be one 90-degree rotation. This would be 2 90-degree rotations, or 180 degrees. This would be our newfound axes if we did a 270-degree rotation. So again, we're pretending that this is our x and our y axes, and we're pretending that this is our newfound origin, and we're just plotting these 3 points, pretending that this was our axes. So B is 7, 1, 1, 2, 3, 4, 5, 6, 7, 1. So I know that B prime is going to be over here. C prime is 6, -6, 3, 4, 5, 6, 2, 3, 4, 5, 6. C prime is here. And then D prime is at 2, 5. So 1, 2, 1, 2, 3, 4, 5. D prime is right here. Now we take our straight edge and we connect our points. Okay, now again, let's turn our paper back, right? Because our location is dependent on us looking at the coordinate grid just like this, right? So B prime, C prime, and D prime, let's locate those. So B prime is at 1, -1, 2, 3, 4, 5, 6, 7. 1, -7. C prime is over here. That's at -1, 2, 3, 4, 5, 6. -6, -1, 2, 3, 4, 5, 6. And then D prime is over here. That's at 1, 2, 3, 4, 5, -2. Okay, so these are the coordinates of the image. And again, if you think about it, right, thinking about this conceptually, I know D and B are going to end up about 3 quadrants away from where they are, right? So this would be 1 quadrant away, 2 quadrants away, and 3 quadrants away, and D prime and B prime do end up there. And then C should also end up about 2 quadrants away. So 1 quadrant away, or 3 quadrants away. So 1 quadrant away is in this quadrant here, 2 quadrants would be here, and 3 quadrants away would be here, right? So you can kind of use that conceptual knowledge to help you justify whether or not your answer is correct. Now, this third example here is going to be a little bit different from the other two because now we have the same exact coordinate points, but we're rotating 180 degrees about a different point. So our center of rotation is changing. Our center of rotation is now 2, 1. So if that's the case, the same exact ideas are going to hold, except we're going to shift our view of where the origin is. So right now, our center of rotation, what we are going to do is draw vertical and horizontal lines through this point. So I drew a vertical line through C, or through our center, and I'm drawing a horizontal line through C, and I'm gonna highlight these because this is gonna be where our pretend new axis is. And the reason we're doing this is so we can use the exact rules that we did last time. But if we're shifting our view of where the origin and where the axes actually are and where they intersect, we need to shift our view of the coordinates of these 3 points. Because originally, the coordinates of B were 7, 1, C was 6, -6, and D is 2, 5. But if we're shifting our view of where the origin actually is, we need to shift our view of the location of these points. So we're going to come up with a set of fake coordinates. So B, if this is our newfound origin and this is our newfound x and y axes here, what we're going to do, B is located at 1, 2, 3, 4, 5, 0. C is located at 1, 2, 3, 4, -1, -2, -3, -4, -5, -7, so 4, -7. And then D is at 0, 1, 2, 3, 4. Now, these are our fake coordinates, right? Because we shifted our view of where the axis is, but the same exact concept as before applies now. So we're rotating 180 degrees, right? So we can imagine our coordinates ending up about 2 axes over from where they are. So D and B should, if they ended up 1 axis away, they'd kind of be here. 2 axes away, D and B are going to be somewhere here. And then C, or 2 quadrants away, so C, 1 quadrant or rotating 90 degrees would end us up somewhere over here, but then a rotation of 180 would end us up somewhere over here. And again, we're shifting where our axes are, so we're also shifting where our quadrants are. So this right here, this region would be quadrant 1, quadrant 2 would be fully right here, quadrant 3 would be this region here, and then quadrant 4 is what we're left with here, okay? So again, we're gonna rotate our paper, so we're going 180 degrees. So we go 90 here, we go 180 here, and now we're plotting these fake coordinates just on this grid, right? So point B is 5, 0. So again, pretending that this now is our x and our y, 5, 0 on our newfound origin, right, would be 1, 2, 3, 4, 5, 0 would be right here. So that's going to be B prime, and I'm writing upside down, so bear with me. C prime is going to be at 4, -7. So 1, 2, 3, 4, -1, 2, 3, 4, 5, 6, 7. C prime ends up here. And then D prime is at 0, 4. So 0, 4 on this axis would be 0, 1, 2, 3, 4. And that is our D prime. Now bear with me, I wrote backwards or upside down, so yeah, our D prime is kind of messed up. But when we flip back, right, we need the actual location. And now the actual location, again, the actual location of points always depends on your real axes. So our real axes is here and here. So our coordinates for B prime on our actual axes, which if we take a different colored highlighter and highlight our actual axes in orange, our actual axis is there. So when we're locating our points, B prime is at, this is our origin, is at -1, 2, 3, -3, 1. C prime is over here, and on our actual axes, that's at -2, 1, 2, 3, 4, 5, 6, 7, 8. And then D prime is down here, and in terms of our actual axes, it's at 1, 2, -1, 2, 3. So again, when you're finding the location, this is based on the real axes. And that's any time you're trying to find, when you're listing the location of your points, that's always based on your real axes. So when we're rotating about a point other than the origin, the process becomes a little bit different because again, we're shifting our view of where our origin and axes are. The only reason we're doing that is so we can use the same concept from here, right? When our origin and our axes were here, we're able to rotate and replot. And in order to use that same logic, we have to shift our axes to be the center of rotation so that we can use that same logic, okay? So what I would do if I were you guys is write down the steps. Again, it really differs when you have a center, not the origin, but we're gonna work with this a little bit more tomorrow.